everybody, a whole group that had marvelous ideas about what we could do to make cities better. And that very little came of that because the UN had a strange bureaucratic system and some new people came in and they sort of swept aside everything that was done, and the history was going to start with them. But I started to sort of reach ahead to look at specific things that could be done for cities. What am I got here? Oh, and I also realized that because, as the UN recently announced, half the world's population, actually more than half, now live in or near cities around the world. So you have this huge concentration of people. Now, Fritz Schumacher had been very renowned for writing the book Small is Beautiful, which is a very lovely book, makes a lot of sense, except that when you have 10 or 15 or 20 million people living together, they can't all dig a well or throw out their sewage in a pit or grow their own food. So you have to start doing these things on what I call a macro scale. You have to have large central electrical systems, large central distribution for gas and oil and steam, and taking the rubbish away, taking the garbage away. Everything becomes a big deal, and it has to be done on what I call a macro scale. And this was, let me see, do I have an eraser here, guys? Is this an eraser? Yeah, let me just get rid of my airplane here. And I'll just make another quick diagram to show you this, the city. The UN defined cities at that time. Oh, here you go. UN habitat. Is a place where people live, work, I'm drawing this in a certain way for a reason here, and play. Well, I thought, no, that's nice, but it seems to leave a few things out. So I went back and added, if you live there, how about getting educated? Live and learn. If you work there, how about communicating with the rest of the world? And if you're playing, how about also self-improvement? What's it called? Actualization, self-actualization. Now, if those are the basic elements of a city, it requires infrastructure. IFS, I like to just shorten that to infrastructure, the provision of that water, gas, electricity, and so forth, the taking away of the rubbish and garbage and sewage, maybe even the provision, it may get to the point where we consider health care and food, because nobody can grow their own, nobody's growing their own food in the city in spite of some small gardens here or there. We're relying on stores to deliver it to us, the same way we rely on somebody to deliver gas and electricity. So infrastructure becomes a real important part of this and relates to each of these just as they relate to each other. And so this becomes the sort of the working framework of a functional city. And the question is, if you're doing things on a big scale, let me just jump ahead a little bit here. If you're doing things on a very big scale, which I'm always calling macro, has to be done. Kai asked and others have asked, what is macro? Well, this is an example of macro. And I'm sorry I don't have a blow-up of this. This is the Dutch storm barrier at Oosterschelde under construction, where they made all these giant structures and then floated them out into the water and placed them across this estuary to be able to block a storm. And this was from the National Geographic, and the whole story is down here. So let me put that down. That fits right in there. That's the whole story of that, and you can look at that after. A truly massive, marvelous undertaking that they accomplished after they had one very serious flood back in the 50s that killed some people and a lot of cows and so forth. But another example of macro comes from Norway. This was their Troll platform, the last of their big oil and gas platforms that they put offshore. It's some 472 meters high. And I forget how many thousands of tons it weighed. And yet they floated it out vertically and placed it in the North Sea and been getting gas and oil out of it. So what I started to do was say, look, you've got this tremendous technology in the Netherlands for storm barriers, and you've got this great technology in Norway, and we could start to put this together into a number of different projects for the US. And I came up with an early one that was to create a storm surge barrier for the New York area, for what they call the New York Bight. And then I realized that the Boston area needed it, and the Delaware Bight might need it, and others up and down the coast. So I said, let me run this whole thing from New England all the way down to Florida and see what happens. So I called it the Megabyte, and that became my first paper on the subject. And it would utilize the technology, especially the technology they have in these bottom cylinders, which are about 30 meters in diameter. And they're really, this very dark photo shows the whole thing under construction out in the fjord. They worked night and day on it. They built the very bottommost parts inside a coffer. And then when it was done, they flooded the coffer and the thing would float because there's a little shell inside the bottom. And then they floated it out to the deep fjord and then added the upper part. And as they went up, it dropped lower and lower into the fjord. And then they finally mated it with the top cabin that was built elsewhere, and then it was ready to be towed out to sea. And they also did one other thing, which I have no picture of at this point. They have been working on the idea of submerged floating tunnels. They wanted to make a roadway along the coast from Oslo down to the lower point and then all the way up the coast to Trondheim, say, perhaps maybe even beyond that. But they didn't want to go around each fjord, and they didn't want to go up and bridge over it and then go down. They wanted a tunnel. So they developed the concept for making a concrete tube that floats, even when it has cars and trucks in it. If it's big enough, it's going to float, and the water's kept out. It floats so much they have to hold it down with cables. And this became their submerged buoyant tunnel idea. And I started to link them together. And this created a very interesting possibility. If you start, say, with a number of these caissons that are tall enough to come out of the water, you suck them into the bottom, and then they stick up out of the water 10 meters or whatever, and you put enough down, if you build a ring with some supports in the middle, and then covered it with a rigid deck, which can be made very strong but very light, you immediately have valuable waterfront property, which can be used for a great variety of commercial, industrial, residential, whatnot, recreational activities, all of which produce revenue. If you want, you could store the waste, the solid waste from every city inside those caissons. And in fact, one of the selling points I had in a separate article was that the solid waste from cities, and especially construction sites, could be the shielding, added shielding for storing nuclear waste. And the US still has no plan for storing its nuclear waste, and Europe is having that problem too. And in fact, the Russians have even, they've been very, very bad in storing waste there. So when the Norwegian company that did this was talking to the Russians about doing some of these platforms way up in the North Sea, the north part, the Arctic Sea above Russia, just east of the Finnish and Norwegian border. I said, maybe we could talk them into storing the nuclear waste there, and then everybody in the world would be happier knowing this stuff was not being dispersed or scattered. and reliable Scandinavians will be watching over it. So that's still pending. That idea is still pending. But I did take it a step further. You had a hurricane here 8 or 9 years ago that swept across Denmark and then went on to blow down a lot of trees in southern Sweden. So reacting to that, I came up with an idea for a storm surge barrier coming up from the northern coast of the Netherlands, sweeping around, running essentially parallel to the Danish coast, and then curving out to sea. And I think that curvature would keep the water from, because the hurricanes in the northern hemisphere turn counterclockwise. So if a hurricane is working its way along here, it's going to be sucking the water out of the Baltic, not pushing it in to flood Copenhagen. So that was one strategy, and then we could have a submerged buoyant tunnel linked to Norway for the export of oil, gas, water, whatever people want to pay for. There was an alternative look at coming in here. I just dotted that in. I didn't think that meant too much. That was going to be possible. But I suggested that one of the possibilities here is here, wherever, using these caissons to form a large, deep water port for container ships. And a ship coming in and mooring out there and unloading could be turned around much faster and get back into service. Like aircraft, when they're on the ground or in dock, they don't make any money. So if the ship could be turned around much quicker and sent back out to sea, they would make more money. So I'm hoping that this might be of interest to the Maersk Corporation at some point in the future when we have it a little more developed. But this is one of the very real commercial possibilities with this. Now we have a movie of another project that could be attached to this, because the whole process of putting these islands out and with a barrier between them, a storm barrier between them, allows you to do other things like mariculture, aquaculture, and putting up wind generators. And it would be far enough offshore that you wouldn't see it. It would be over the horizon for anybody on the beach. So aesthetically, you wouldn't notice it, but you would be able to get these the energy and maybe capture wave energy too, if that's possible. Maybe Jay, maybe we'll run that. Let's run that. So we have one tape of one activity that could be very, very beneficial and is sort of attached to that, and do a lot of good for the area and for the fishing industry, for the fish business.